Good morning, friends. Here, as far as possible, the dimensions as given reflected from actual view of a cantilever. Here, mass to the top attachment hole center where stay tube is fixing, the distance is 125 millimeter. Then in the stay tube adjuster is in front of it. From the adjuster hole center to the bracket tube center point, it is 50 millimeter. Then from the bracket tube center line to the suspension bracket hole center where the suspension clamp catches, that is 110 millimeter. The suspension clamp hole center to the contactor center is 70.5 millimeter. Encumbrance, we know it is the distance, axial distance of contact and catenary wire. It is a variable quantity, encumbrance, as per the height of contact wire, because in overland structure the encumbrance is reducing, so it is a variable quantity. Normally in normal OH it is 1.4 or 1400 millimeter. The registration tube to contactor center, it is called steady clearance. It is around 300 millimeter. And F from contactor center where the bottom attachment fixed in the mast, the center point is F. It is also equal to 300 millimeter. The distance between the bottom attachment center point to the bottom attachment where bracket insulator fixed, that distance is 156 millimeter. The hole center of bottom attachment and the bracket tube where it catches the bracket insulator, that distance is 200 millimeter. So it has been shown here, and according to this dimension we will calculate the length of the tube B, bracket tube. The length of the bracket insulator is also around 500, or as per the requirement or modification. Good morning, friends. Today we discuss how to calculate the length of bracket tube, stay tube, registration tube and steady arm. It is indicated in B, A, C, D. So in the figure you can see that bracket tube has formed a triangle OAN and its angle is theta 2, and an imaginary line ON where the suspension clamp and suspension bracket meet, that center ON. So another triangle is ONC, and the angle in between OC and ON is theta 1. First we will discuss the length of the bracket tube. Let's start. From the figure we are getting two triangles. One is OAB and another is OBC. Now BC how much? It is the distance of the suspension clamp, that means 70.5 plus encumbrance. Then we have these two conductor, then again plus F, because we cannot able to reach C directly. So what we will do, 70.5 plus encumbrance plus F, then subtract 156, the distance of the bottom attachment center to the whole center of bottom attachment where bracket tube catches it. So that distance is 156. So now we can reach in this way to the point C. And we know from track center to the mast face it is L, or implantation. So OC is equal to how much? Implantation L minus 200, because the bracket insulator and bracket attachment, bottom attachment, the distance from mast is 200 millimeters. So OC is equal to L minus 200, and we have got BC. So we can get ON. We can get ON, but we have to find out the length OA, that means the bracket tube length. So what it will be? OA square is equal to OB square minus AB square. OB square minus AB square. AB we know it is 110. AB is equal to 110. So if we square root these values, then we can get the length of B. But this B length is included the length of the bracket tube, bracket insulator, plus some projection of the bracket tube is also to be given around 200 millimeter. So you can find out the length easily. From the B you subtract the 500, then add the 200, around almost approximately you will get the length of the bracket tube. In the same way, next we will discuss the length of the A, that means stay tube. The system is also same. Subtract the length of the stay tube, stay insulator, and the adjuster hole, how much you will take to place the catenary on the track center. In the curve you can shift the catenary also 100 millimeter from the track center, but in tangent track your catenary should be on the track center. Thank you friends. Try to solve this problem.